Right, here is an investigation paper. It is from June 2013. The beginning of paper 6, diagonals of rectangles. Rectangles are drawn on a grid. The sides of each rectangle lie on grid lines and the length is greater than or equal to the width. So the length is always classed as the longer distance. They could potentially be the same, which would mean it was the square. This investigation looks for a method for calculating the number of small squares through which a diagonal passes. Number 1. The diagram shows a rectangle with length 5, 1, 2, 3, 4, 5, and width 3, 1, 2, 3. The diagonal shows 4 vertical grid lines inside the rectangle. So when it says vertical grid line, the vertical lines are these lines here. So inside the rectangle, so it's not counting this one here or this one here. So the 4 inside are here, 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 and here. 4 vertical grid lines, right? Write down A, the number of horizontal grid lines that the diagonal crosses inside the rectangle. So the diagonal is the line that goes from one corner of the rectangle to the other. So this line here is the diagonal. And it's asking how many horizontal grid lines does it cross inside, right? So it's going across, the first one it crosses is here, 1, and then it crosses this one, 2. So the next one is no longer inside, so it's just 2. The total number of grid lines that the diagonal crosses inside the rectangle. So it's going to cross the 4 vertical grid lines that we've been told about already, plus the 2 horizontal. So 4 plus 2 just gives us 6. Right, number 2. So already we're into the algebra. So straight away we've suddenly got an x and a y. A rectangle has length x and width y. Write down an expression for the total number of vertical grid lines that a diagonal crosses inside the rectangle in terms of x, right? The number of vertical grid lines. So if you think about it, right, this diagonal has got to get from here to here. So it's going to cross every single vertical line inside. And if you think, well, x was 5 here, so it crossed 1, 2, 3, 4 of those. And if you think about it, it's always going to be 1 less than the length of the rectangle because it doesn't need to cross this one. So at the edges, it's already in there. It doesn't cross this line and it just touches this line, but it does cross 1 less than the number. So the length number. So it's going to be x minus 1. The number of horizontal grid lines that a diagonal crosses inside the rectangle in terms of y. So we use exactly the same reasoning. Remember, for the first rectangle, y was 3, and we crossed 1, 2 times because you only have to cross this line and this line. You don't need to cross the line at the beginning and the line at the end. Remember, these rectangles are always drawn so that they start on a corner and they end on a corner. It does say that at the beginning. So it's just going to be y minus 1 for that one. Right, now we need to write an expression for the total number of grid lines, n, which a diagonal crosses inside the rectangle in terms of y, so in terms of x and y. Write your answer in its simplest form. So this is just, it's the horizontal grid lines plus the vertical grid lines. Or we did vertical first, so vertical first. So n is going to equal, well, the number of vertical grid lines we passed, which was x minus 1, plus the number of horizontal grid lines that we cross, which is y minus 1 plus y minus 1. Well, x minus 1 plus y minus 1 is x plus y minus 2. Plus y minus 2. Right, S is the number of squares through which the diagonal passes. For example, the diagonal in question 1 passes through 7 squares. So let's just verify that. It's saying it goes through 7 different squares. So you can see it goes through this square 1, this square 2, this square 3, 4, 5, 6 and 7. So that's good news. Write S in terms of n. Right, so the first clue, we know that when n for the first one was 6 and it passed through 7 squares, so that looks like it is one more. So could we just have a think about why this might be one more? So if you consider the journey of this diagonal, just imagine it as a journey from the bottom left to the bottom right. We're already in the first square, and then every time we cross a line, we go into a new square. So the number of crossings, remember, is n. So the number of times we actually cross a line is n. And then we're already in the first square to begin with. So that explains why this s equals n minus 1 makes sense. So we were sort of given a clue that when n was 6, s was 7, which is n plus 1. And then it does make sense because every time we cross one of these grid lines, whether it is vertical or horizontal, we go into a new square and we're already in the first square to start with. So that tells me that s equals n plus 1. Write down s in terms of x and y. So this shouldn't be too bad because we already know what n is in terms of x and y. So we'll just go back and have a look at that. We know that n is x plus y minus 2 and s is n plus 1. So that means s equals, well, if we just substitute in for n, x plus y minus 2, x plus y minus 2 plus the 1, and then just simplify that. Well, x plus y is just x plus y, minus 2 plus 1 is minus 1. X plus y minus 1. Show that your formula for s in part B2, which is the one we've just written down, gives the correct value for an 8 by 5 rectangle. Use the grid to show clearly how many squares the diagonal passes through. So we've been guided in exactly how they want us to do this. So this is an 8 by 5 rectangle. We should just check that. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. That's fine. We need to draw the diagonal. Right, and I think the easiest way to show how many squares it's passing through is just to put some numbers in. So it goes through this one, 1, 2, 3, 4, 5. It just passes through this one, 6, passes through this one, 7. It does just get into this. It is very important that you draw the diagonal as accurately as you can. So it just about goes into this square, so we must count it. 8 definitely goes through that one, 9, 10, 11, and 12. So according to the drawing method and counting squares, we are passing through 12 squares. So let's write that down. By the formula, well, s should be x plus y minus 1. Well, x was 8, y was 5, so 8 plus 5 minus 1. 8 plus 5 is 13, 13 minus 1 equals 12. So it does work. Okay. Question 3. In question 2, x and y did not have a common factor. Remember, x was 8 and y was 5, so the only common factor was 1, which doesn't really do anything. In this question, x and y do have a common factor, so this is probably going to complicate things a little bit. Show clearly that your formula for s does not give the correct value for a 9 by 6 rectangle. So just check that they've drawn as a 9 by 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. So we'll just do the same thing as before, and we're hoping it's not going to work. Draw the diagonal. Count the squares in the same way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, so there are 12 squares, and our formula would be well, it would be 9 plus 6. So S, using the formula, would be 9 plus 6 minus 1. 9 plus 6 is 15. 15 minus 1 is 14. So that shows us a formula doesn't work. Formula doesn't work here. Right. 9 and 6 have a common factor of 3. Show how you will use the factor, the value of S for a 3 by 2 rectangle to calculate S for a 9 by 6 rectangle. Now the problem that we had, the reason why this didn't work is because of these points here. So if you just look here, you can see that the line crosses. Well, it crosses on a diagonal, and that happens here and here. And when that happens, if you think about it, you're crossing a vertical and a horizontal line at the same time, and you're only going into one new square, so you can see why that would mess things up. So that happens twice, so we're 2 out. So what you look at, if you can see where I've drawn this point, well, if I just sort of draw down here, that is a 3 by 2 rectangle. So what we can do, we can use that, use the formula, because the formula will work in here because we don't have any of this problem here. And then we can just work out S for this particular 3 by 2 rectangle, and then we can just say, well, we've got 3 of these. Then you're getting this line here, and you're just repeating it. So you end up with the same line 3 times. So that will get around this problem, and the formula will still work, and you'll be able to apply it for a common factor. Well, not the formula, but a formula. So what that means is, so if you have a 9 by 6 rectangle, so 9 by 6, well, that is 3 times a 3 by 2. And then 3 by 2 we have drawn, so S for 3 by 2, well, it's going to be 3 plus 2 minus 1. So this is going to be 3 plus 2 minus 1 equals 3 times, well, 3 plus 2 is 5, 5 minus 1 is 4, and 3 times 4 equals 12. And we did have 12, so it works perfectly. And you can see what we're doing. So we're working out for this rectangle, then we're scaling it up 3 times. We get around this issue when we pass on the diagonal. Use your method in part A2 to find S for each of these rectangles. So you've got a 93 by 90 rectangle and a 60 by 35 rectangle. So when it says part A2, always make sure you know what you're talking about. So this was A2. So we're going to use this common factor method. And it's really quite deep into the paper now, so it's really quite generous. So 93 by 90 by 90, well, that equals, the common factor here is 3. You could use I'm actually doing this one without a calculator just because there's not much complicated maths, there's no difficult sequences or anything, but by all means, if you wanted to use a calculator to work out these factors, it is available to you. But I know that 93 is 3 times 31, so it's 331. I know 31's prime. And then 90 is 3 times 30. And 31 and 30 do definitely not have any common factors, so that's fine. So S is going to be 3 times, well, whatever the S would be, the number of squares in a 31 by 30 rectangle. So it would be 31 plus 30 minus 1. 31 minus 1 is 30. 30 plus 30 is 60. 3 times 60 is 180. So it would pass through 180 squares for that. 60 by 35, exactly the same method. 60 by 35 equals, well, the common factor here is 5. So you can see this ends in 0, this ends in 5. 5 12s are 60. 5 7s are 35. So this is 5 times a 12 by 7. So it's going to be 5 times 12 plus 7 minus 1. 12 plus 7 is 19. 19 minus 1 is 18. 5 times 18. If you want to times something by 5, you can times by 10 and then half it. 5 times 10, 180. 180 divided by 2 is 90. S equals 90 for that. Okay, this is actually the last question on the paper, so it's really been quite a friendly one. The diagonal of a rectangle passes through 6 squares. We're doing a bit of reversibility now. Use question 2 and question 3 to find the length and width of each possible rectangle. Okay, so question 2, what method? For question 2, this was our method to calculate the number of squares it passes through. It was S equals x plus y minus 1, right? So it definitely wants us to use that, but it also wants us to use what we've done in question 3, which was well, think of it, it could be that you've got a common factor and you need to scale up that way, right? So if you think of all the combinations, well, if we go straight to one rectangle, well, then that would mean, if it just passes through 6 squares, that would mean x plus y minus 1 equals 6, which would mean x plus y equals 7, right? So your possibilities for this are, remember, x always needs to be greater than or equal to y, so because x is the length and y is the width. It told us that earlier on. So you could have a 6 by 1. You could have a 5 by 2 to make 7, or you could have a 4 by 3. So that's all the possibilities for just one rectangle. Then what you could have is you could have it passing through 3 squares, but then you need to multiply the answer by 2 at the end, so which would really get your 6 squares from. So could pass through 3 squares and we multiply by 2 at the end. So if you pass through 3 squares, that would mean x plus y minus 1 equals 3, which would mean x plus y equals 4. So your possibilities for that would be, well, you could have, remember, x always needs to be greater than or equal to y, so you could have a 3 by 1 or a 2 by 2. So 3 by 1 or a 2 by 2. But you do need to be careful about this 2 by 2, because if you look at that, the formula wouldn't work for anything when x and y have common factors. So we disregard that one. And the 3 by 1 isn't really a 3 by 1. Remember, it's a 2 times 3 by 1, which ends up being 6 by 2, which is one of our methods. So if we had 6 by 2, we would call that 2 times 3 by 1. We would do 3 plus 1 minus 1, and then we would multiply the answer by 2. Right, so I'm running out of space a little bit, so I'm going to say could pass through 2 squares, which would mean we times by 3. So we'd have x plus y minus 1 equals 2, which means x plus y equals 3, which would mean you would have a 2 by 1, which actually, if you think we need to multiply both of these by 3, so 2 by 1 would become 6 by 3. We have one more possibility, would be if it just passed through 1 square and we need to multiply it through by 6. Could pass through 1. Only 1, right? So to pass through only 1 square, well, x plus y minus 1 equals 1, which means that x plus y equals 2. And the only way you're going to get that is 1, 1. And if it's 1 and 1, we times by 6. which means it's a 6 by 6 square. So that is our final possibility. If you think of a 6 by 6 square, it does make sense because it would pass through the diagonal every single time, so it would only go into 6 squares.